Okay. So important thing to take forward from here is the cosine formula can be used in these two conditions. Number one, all the three sides of the triangle are known, or the second scenario, any two sides of the triangle and the included angle is known. So just remember these two conditions well. We will be using them in our question.
Now let us take this great circle concept that we have learned onto surface of the earth, and let us just review or discuss the features of great circle tracks on the surface of the earth. The great circle track between two places implies if we have two places on the surface of the earth and we are talking of GC track between them, it means we are talking of the smaller arc of the great circle passing through the two positions. What does it mean? You can see in the diagram, we have the surface of the earth, we have the two poles, North Pole and South Pole, equator also showing up. Then you have position A, then you have position B on the surface of the earth. And now you have this great circle passing through A and B, because we said unless the points are diametrically opposite to each other, you will have one and only one great circle passing through them. Now in this great circle, there are these 2 points divide the great circle into one is the smaller arc and the other is this bigger arc. So whenever we talk about the great circle track, we shall talk about the smaller track, smaller arc, and you can see which is now being shaded in red. So the BC track between A to B or B to A shall be this arc of the great circle, that is the shorter arc.
So this is also clear, beta?
Yes, sir.
Right, very good.
We shall talk about the smaller track, smaller arc, and you can see which is now being shaded in red. So the BC track between A to B or B to A shall be this arc of the great circle, that is the shorter arc. The BC track is always curved with its convex side pointing towards the pole as follows. Now when you move along the GC track, it is along a curve on the surface of the earth, and the curvature, the convex side of that curve is always pointing towards the pole. Now the question is, we have two poles, North Pole and South Pole. Towards which pole does the track curve and present its convex side? Now, if both the positions lie in the same hemisphere, that means arrival and departure positions are either in both in northern hemisphere or both in the southern hemisphere, the convex part shall be towards the pole of the hemisphere in which both the positions lie. For example, you can see in this diagram, if A and B lie in the northern hemisphere, the great circle track between them will have its convex part pointing towards the North Pole. You can see the other diagram here. If A and B lie in the southern hemisphere, both of them, then the great circle track shall have its convex part curved towards or presented towards the southern pole.
Now, beta, this is not very important when we are solving the questions. This is required basically to make the diagram. So even if you don't remember it, that the curvature has to be towards the pole and you just join them by a straight line, as far as your answers are concerned, the answer will still be correct. The formula, cosine formula, will take care of your answers. However, it is good to be aware of how the diagrams are made. So that way it will be very easy for you to pick up if there is a diagram made in any book. You will be able to understand why it is curved in a certain way. So is it clear up to here, beta?
Yes, sir.
Okay.
Yes, sir.
Very good.
Yes, sir.
Both positions lie in the opposite hemispheres. That means the departure and arrival positions do not lie in the same hemisphere. Then the track shall curve and present its convex part towards the pole of the hemisphere in which the position has the higher latitude. Whichever of the two has the higher latitude, that particular pole would be the pole towards which the convex part of the curved track shall be presented. You can see in this diagram, we have position A in the northern hemisphere, we have position B in the southern hemisphere. Needless to say, latitude of B is higher than the latitude of A. So the track between AB or BA is curved towards the southern pole because the southerly latitude is higher than the northerly latitude. Now, there can be a situation in which both the places lie in opposite hemispheres, but both positions have the same latitude. In that case, the great circle track shall be somewhat like this. In their respective, so the track in the northern hemisphere will have its convex part towards the North Pole. The track in the southern hemisphere shall have its convex part towards the southern pole. And in this case, both A and B are equal in value, but opposite in names. So the great circle track between A and B shall be somewhat like this, what you're seeing in the diagram. Now, great circles questions can be easily handled if we follow certain definite steps like a drill. So the steps involved in solving the great circle sailing questions are.
Okay, so beta, the spherical trigonometry concepts are covered now. Just to give you a recap, the first important concept was of great circle. What is a great circle? Second important concept which we did was what is a spherical triangle? And the third important concept which we did was cosine formula. So if these three things are clear in your mind, you can easily solve a great circle sailing question. Now,
Excuse me, sir.
bolo beta.
Sir, there is a slight doubt.
Bolo.
That in great circle, when we are having the positions in two different hemispheres, while drawing a diagram, the correct diagram is when we show that if for example, the initial position A is in the southern hemisphere and the other position in the northern hemisphere, then while drawing the diagram from A to B, uh, from point A up to the equator, we show the convex in the towards the southern pole, and from the equator up to the final position, we show the convex to the northern pole. So is that correct?
Right, beta. That is correct. That is correct. I'll show you on a whiteboard. Just give me a minute.
It's the same thing, no, sir? It's the same thing because when it's in North Pole, on the northern side, it should be on the northern side, and in the southern sphere hemisphere, it should be on the southern side.
Yes, that's right. I'll just show you here. Mind my drawing skills. I am doing it with a mouse. So let us say you have one position here. This is our starting position. And let us say you have one position here. Let's say this is our North Pole. Let's call it Pn. And this is the South Pole. Let's call it Ps. Now, let me draw, if I want to draw a great circle track, let's call this as point A and point B. If you go deeper, the accurate and exact way of drawing a great circle track would be uh, from point A up to the equator, it should be curved towards the South Pole. I'm just giving it a curvature so that it becomes clear in your mind, something like this. And when you go in the northern hemisphere, the curvature is towards the North Pole. So you can see here the curvature is toward the South Pole, and here the curvature is toward the North Pole. If you go more deeper, this is how exactly the great circle track is drawn. I think you are talking about this only, beta.
Yes, sir, that's correct. And just one more thing, if we because the diagram obviously has its own marks during the steps of this question. So if we draw the previous diagram, the basic diagram, taking in consideration that which latitude is higher, so is that the correct one, or should we consider this one to be the correct one? Should what
This
should
is
we
the
draw in the exam?
this is the correct one, beta.
Okay, sir.
Okay. However, why is that shown in the video is because usually that much importance is not given to the diagram. So just to make it easy for you, so that you don't get confused making the diagram, sir has just told that whichever is the higher latitude, you take the curvature there. But if you go deeply into it, this is how the actual great circle track would appear.
Okay, sir.
सर वन डाउट
Bolo beta.
सर ये जो डायग्राम अभी जो मतलब बना हुआ है ना इसमें सर ये ग्रेट सर्कल जो दो पॉइंट होते हैं दो पॉइंट उनके बीच में एक ही मतलब ग्रेट सर्कल पास होता है तो ग्रेट
Right.
सर्कल सर एक स्ट्रेट लाइन होती है ये यहाँ से टेढ़ी मेढ़ी मतलब बन रही है तो ये चलेगा सर कि ऐसे होगा
ओके ओके बेटा, ये जो कर्वेचर हमने शो किया है ना, ये बेसिकली डायग्राम बनाने के लिए है। एंड ये टेढ़ी मेढ़ी इसलिए दिखाई देती है क्योंकि जो डायग्राम हम बना रहे हैं ये एक 3D डायग्राम है। इट्स ए 3D डायग्राम। वी आर ट्राइंग टू शो ए कर्व्ड सरफेस ऑन ए फ्लैट सरफेस। जो सरफेस हम शो करना चाहते हैं वो तो एक 3D सरफेस है, पर उसे हम दिखाना चाहते हैं एक 2D सरफेस पे। आवर स्क्रीन इज ए 2 डायमेंशनल सरफेस, बट दिस ट्रैक इज मेड ऑन द सरफेस ऑफ अर्थ विच इज ए कर्व्ड 3D सरफेस। इसलिए हमें ये ऐसे कर्वेचर में दिखाई दे रही है। ओके, सो एक्चुअली इफ यू हैव ए ड्रोन and or a rocket, and you launch in that rocket and you have a look at the great circle from space onto the earth, that would appear exactly as a straight line. Okay, यहाँ पे हम इसे 2D में शो करना चाहते हैं, इसलिए ये कर्व्ड दिखाई दे रही है।
He is asking, I think, is in this great circle between point A to point B, there are two curvatures. So in the examination, we have to draw this two curvature or single from point A to point B straight away like that. I think.
Beta, I would recommend you draw it like this.
Because in the second mates for the same question, like I did it from Mumbai, Masa. So we used to draw from point A to point B a straight curvature, not the two curvatures. That's what I'm asking. And it
See,
was correct. That's why it's getting confusing.
see, as I told you, even if you draw it as a straight line without any curvature, as far as your answer is concerned, the answer will be accurate because the answer is dependent upon the application of cosine formula. Answer is not dependent on the accuracy of your diagram. The answer would still be accurate. But if you want to be diagrammatically correct, then you should be showing the curvature as we have shown here. Is it okay,
ओके
beta?
सर
Did you get it?
So in practical way, if we have to show this line from A to B on a Mercator chart, will it be shown like this only, sir?
Okay, now we are doing this. We are showing this on the surface of Earth right now. If you show it on a Mercator chart, okay, let's say we have a Mercator chart. You have the equator somewhere here, and if you show the track, it would be this wavy kind of track here also. Okay, it will be like this on the Mercator chart. It will not be a straight line. It will be a curved track.
Okay, sir. For with both the curves.
Yes, it will have both the curves. Southern hemisphere, it will be curved towards the South Pole, and northern hemisphere, it will be curved towards the North Pole.
Okay, sir.
Sir, now in the same diagram, obviously we are going to draw a complete triangle. So now in the same diagram, if we are having like the A latitude is higher, so we will just join point A and point B to the southern pole, right, sir? Whereas the
Okay,
curve is like this only.
let's take an example. Let's say A is latitude. What latitude you want to take, beta?
Maybe 20, sir.
20 degrees south.
Yes.
Okay, the A's latitude is 20 degrees south. And what latitude you want to take for B?
10 degrees.
Okay, so B's latitude is 10 degrees north. Okay, now the question arises is which pole should we be taking? Let me erase this straight line. So the question now arises is which pole should we be taking? Now in this case, when you are going from one hemisphere to other, whichever position has the higher latitude, it is better to select that particular pole. So in our case, the higher latitude is of A. A being in the southern hemisphere, it is better to make the triangle with the south pole. We will be making a PAB triangle in this case. So it is better to make the triangle with the south pole like this. So this will be our PAB triangle.
Okay, sir.
So when both are equal, we can take from anywhere.
Okay, when both are equal, let's say the B's latitude is also 20 degrees north, then in that case you have a choice. You can take it from whichever pole you like, but in that case I would recommend you take it from the north pole. It is always better to see the triangle with the pole upwards. So otherwise it is your choice. With the latitude being same, the triangle can be made with any one of the poles. Okay, beta, clear?
Yes, sir. Clear.
Okay, all right. So let's go back to the video. So now since we have understood the cosine formula, the two conditions in which it can be applied, we can now proceed ahead to solve a great circle sailing question. So let us see what are the steps involved. How do we proceed ahead in solving a basic great circle sailing question? As I
Sir,
told you, a basic great circle question will have initial position and final position given to you. This is the data which is provided to us, and we are required to find out the great circle distance, the initial course and the final course. Go ahead, beta.
सर इन द लास्ट डायग्राम अगर कर्वेचर अगर हम लोग ऑपोजिट ले लेंगे तो क्या डिस्टेंस में फर्क आएगा?
Okay, you mean to say that if you take the curvature like this,
यस सर.
बेटा आप कर्वेचर
डिस्टेंस में फर्क आएगा इट विल बी मोर
आप ये कर्वेचर कैसे भी ले लो, आप इसे रेड कलर के वे में ले लो या ब्लू कलर के वे में ले लो, या आप
यस.
एक स्ट्रेट लाइन ड्रॉ कर दो,
यस.
आप कैसे भी डायग्राम को बना दो, आपके
यस.
डिस्टेंस में कोई फर्क नहीं आने वाला, बिकॉज द आंसर डिपेंड्स अपॉन एप्लीकेशन ऑफ द कोसाइन फॉर्मूला. It does not depend upon the accuracy of your diagram.
यस.
Okay. So in all these cases, what is going to be having a problem is just the diagram, not your answers.
ओके सर, थैंक यू.
Okay. Or doubt, beta?
नो सर, थैंक यू.
Okay. All right. Okay. So let's proceed ahead with the solution.
यस सर
First, we need to plot or mark off the departure position, and in relation to the departure position, we need to mark off our destination positions. So if I wish to call the departure position as A and destination position as B, then I need to mark off B in a relatively correct place with respect to A. What does it mean? It means that depending on the DLAT from A to B, we decide whether B would be marked north or south of A. So if D lat is north from departure to destination, then B is marked north of A. If D lat is south, B is marked south. Likewise, we evaluate the D long from departure to destination, that is from A to B. If D long is east, then B is plotted east of A. And if D long is west, B is plotted west of A. So therefore, based on names of D lat and D long, we mark off position B with respect to position A. Then we make the spherical triangle with appropriate pole. Now, appropriate pole here means the pole towards which the great circle track shall present its convex part. So we have already dealt with as to which side or which pole would the convex part be presented, and to whichever pole we expect the convex part to be presented, that shall be the appropriate pole as far as making this diagram is concerned. Then we get a spherical triangle whose vertices are the pole, position A and position B, PAB triangle. The three sides of the spherical triangle are then PA, which is arc of meridian of the departure position from pole to A, PB, arc of meridian of destination position from P to A, P to B, I'm sorry, and AB, the arc of great circle track contained between A and B. Now we have to load these parameters as we calculate onto the diagram or the triangle that has been made. Now, drawing an appropriate spherical triangle and loading with given parameters can be seen in this small illustration. We have the sphere of the Earth. We have the equator of the Earth showing up. If I have this as the equator, I have the North Pole, I have the South Pole marked. Now, if I have to take two positions, a position A out here in the diagram, and I take position B, which is position here, then I can draw the meridian of A, which comes up here. Likewise, we can draw the meridian of B. That's the B. Now we draw the arc of great circle that passes through A and B. Now this is the arc of great circle which passes through A and B. Now we have the spherical triangle which is formed by PAB. This is the spherical triangle of interest to us. Now in this case, this is the GC track from A to B.
Okay, so is this triangle clear, beta? PAB Papa Alpha Bravo triangle on the surface of Earth?
Yes, sir.
Okay,
Yes, sir.
so in this beta, the red color side which we have, that is the AB side, it is a great circle track. And why we have drawn a great circle? Because we want to find the great circle distance between A and B. Now, what is this line PAC? Can you tell me, beta? Papa Alpha Charlie?
The part of the meridian.
Very good. It is
Meridian.
part of the meridian of our starting position A. Now we know all the meridians are great circles. So this tells us that this particular line is a great circle. Similarly, the line which you see Papa Bravo Delta is the meridian of B. So all the meridians are great circles. So we know the side Papa Bravo of this triangle is also an arc of the great circle. So you have this triangle Papa Alpha Bravo PAB triangle. It is made on the surface of Earth, which is a sphere, and all three sides of this triangle are arcs of great circles. So which triangle is this?
Spherical triangle.
Very good. This is a spherical triangle. And
Sir,
bolo beta.
Sir, I have a doubt. You told that all meridians are these great circles.
Right. Right, that's right, beta. All meridians are great circles. A meridian and a anti-meridian or inferior meridian joined together completes one great circle. Is it clear, beta? You still have some
Yeah,
doubt?
clear. Clear,
Okay,
sir. Clear.
okay, beta, okay. Okay, so we have a spherical triangle, Papa, Alpha, Bravo. Now, beta, can you tell me this arc of the meridian between A to C? This is the arc of the meridian contained between the equator and a particular position. What is this called?
The latitude,
Very good.
latitude of
Very good, beta.
Sir, this is yeah.
This is the definition of latitude of any position. Arc of the meridian contained between the equator and that particular position. It is called as latitude of A. Now we know pole to equator. If
90
you
है
measure the arc of
90 माइनस
meridian
हो गया
between the pole to equator, that is 90 degrees. So we know Papa to Charlie, P to C is 90 degrees. We know A to C is equal to the latitude of A. So can you tell me what will be Papa Alpha?
90 minus latitude.
T
Very
minus
good.
AC.
Very good. It will be 90 minus latitude of A. So that is also known as colat of A. Okay. Similarly, on this side, the Papa Bravo side of the triangle will be 90 minus latitude of B. That is colat of B.
कोलेट हाँ ठीक है कोलेट
Right. So Papa Bravo will be the colat of B. Colat means 90 minus latitude. Okay. Now beta, in this triangle, this angle P which is being made, it is the angle at the pole contained between meridian of A and meridian of B. So can you tell me what is this definition for?
डी लॉन्ग सर
D long.
Very good, beta. This is the definition for D long. So difference of longitude. It is the D long. This angle P will be the D long between A and B. So once you understand these concepts, it will be easy to solve this triangle now. In a normal or basic great circle question, we are provided with the latitude and longitude of starting position A, and we are given the latitude and longitude of our destination position B. So when you have their lat long, you can find out side PA, you can find out side PB, and you can also find out angle P. Once these three parts are known to us, we can easily apply the cosine formula here because two sides and a included angle is known. So this is the procedure which we follow. So let's proceed ahead and watch this in the video now.
Now this green shaded arc is the arc of meridian of A from P to A. Up to equator, we all know it's 90 degrees. From equator to A, this arc is equal to latitude of A. So therefore, this side becomes 90 minus latitude of A. Exactly the same way, PB becomes 90 minus lat of B. So now in this triangle also, this is the meridian of A, and this one is the meridian of B. So if I know the longitudes of A and B, then this angle becomes D long between A and B. So this angle is the D long from A to B, in case I'm going from A to B, and it would be D long from B to A if I'm going from B to A. So now in this spherical triangle, if I know the coordinates of the departure position, I can get the latitude, side B, PA. If I know the coordinates of B, I can get this side PB. And if I know the longitude of A and B, I can get angle P. In other words, I can get the two sides and the included angle. Now, having drawn the PAB triangle, having transferred the available information onto the triangle, we are ready to solve the triangle. We solve the triangle using the cosine formula, and in solving so, the side AB of the PAB triangle that we shall obtain, when expressed in minutes of arc, shall be the great circle distance between A and B in nautical miles. I repeat, AB, when expressed in minutes of arc, shall be the GC distance between the two positions. Again, we can solve for angle A of the PAB triangle. Please note that angle A shall be the internal angle of the spherical triangle PAB, and this angle A can be used to evaluate the initial course of the vessel. Angle B of the PAB triangle, the internal angle again, can be calculated and used to evaluate the final course of the vessel. How do we evaluate initial and final course using angles A and B?
Okay, so beta, we will be applying the cosine formula and finding these three things. We will find side AB of this triangle. The side AB is going to give us the great circle distance between them. 1 minute of arc of any great circle on the surface of Earth is equal to 1 nautical mile. So if we measure the arc AB of our PAB triangle and convert it into minutes, it straight away gives us the great circle distance between the two positions in miles. Now to find the initial and final courses, we need to calculate angle A and angle B of the spherical triangle. So we will again find these angles using the cosine formula. Once these angles are calculated, we can easily obtain our courses, initial and final courses. The angles which you calculate may or may not be equal to the course. The course would be a different value. So how to find out the course from the angles of the triangle? This is what we are going to see now.
We shall just list down few steps and then see the same or apply the same to few illustrations to understand this issue. First, in the PAB triangle, we shall identify the direction of north at A and north at B, which shall be the northward direction of the meridian, respective meridians of A and B. The courses, we all know, are measured clockwise from true north up to the ship's head and expressed in three-figure notation. Let's take this example. We have the North Pole out there on the screen. We have position A out here. We have position B coming in here. These are the meridians of A and B. And then we have the GC track between A and B. Now, in this, A is the departure position, B is the destination position. When you solve the PAB triangle, you shall be getting this as angle A, and this shall be angle B. Now, when the vessel sets sailing from position A and reaches position B, the vessel shall be placed at A the way you see in the diagram. When she reaches B, she shall be placed the way you see it here. Now, you can see in this case, what will be the direction of the north at A? This will be the direction of north at A. This shall be the direction of north at B. Both these are shown as N in the diagram. Now from this, if I measure clockwise up to the ship's head, this shall be the initial course out here, which is represented by the blue arrow. This represents the initial course, which we see that angle A and the initial course happen to be same. Now when the ship reaches at B, again from the north, we go clockwise up to the ship's head, and this blue arrow represents the final course. But when you solve the triangle, you are not getting this angle. What you're solving is internal angle B. So we can see in this case, the final course shall be 180 minus angle B. In this case, initial course is equal to angle A, and the final course is 180 degrees minus angle B. This is how A and B are used to evaluate initial and the final courses.
Okay, so beta, did you understand this calculation of the courses from the angles of the triangle?
Yes, sir. Understood,
Yes.
sir.
Yes, sir.
Okay, just have a good look at it. Let me know if there are any doubts coming to your mind.
No, sir.
Okay, very good. So let's proceed ahead.
Let's look at another example then. Here is the North Pole, again position A, position B, meridian of A, meridian of B, great circle track through the two. Please note the great circle track is curving towards the, or presenting its convex part towards the North Pole. Now in this case, angle A, calculated angle A would be this one, and calculated angle B would be this much. Let's place the ship both at A and B. Let's mark the initial course at A, clockwise from true north. I'm sure you'll all agree with me that the blue arc represents the initial course. What we have calculated is this angle, and it's very evident from the diagram that the initial course shall be 360 degrees minus the calculated angle A. Let us now mark off the final course at B, clockwise from north. I'm sure you'll agree with me, clockwise from north up to the ship's head is the final course. What you have calculated is this as angle B. This angle B out here shall be equal to this angle. Why? Because they are vertically opposite. And this final course then would be 180 from here to here plus angle B. So in this case, the initial course is 360 degrees minus angle A, and the final course is 180 degrees plus angle B.
Okay, so in this case, beta, you see the ship is moving on a westerly direction track. The first example which we saw, the ship was moving on a easterly track. So in this case, the initial course is 360 minus angle A of the triangle, and the final course is 180 plus angle B of the triangle. So let me know if you have any doubts in this diagram, beta.
No, sir.
Okay, great. So we have seen the ship moving in the easterly direction and the westerly direction in the northern hemisphere, where we considered the North Pole. Let us now consider the South Pole also. So with the ship in the southern hemisphere, how does the calculation of courses, uh, how is the calculation of courses done from the angle A and B of the triangle?
Let's just take one more example. We have the southern pole in this case. We have position A, position B, meridian of A, meridian of B, and we have the GC track from A to B. Please note, presenting its convex side to the southern pole now. Angles, when you calculate, this would be the angle A that you will obtain, and this shall be the angle B you will obtain. The north direction at A would be represented by this side, and this would be the north direction at B. So let's mark the north directions and place the vessels at both A and B. Now let's mark off from north clockwise up to the ship's head the initial course. You can see this blue arc out here. This represents the initial course. And what do you see in this case? This is angle A. From here to here is 180 degrees. So the initial course shall be 180 degrees plus angle A. Likewise, let's first mark off the final course at B. Final course at B shall be this one. What you have calculated is this angle B. This angle B is equal to this one, which is vertically opposite. And what do we see? Final course is 360 degrees minus angle B. So in this case, the initial course is 180 plus angle A, and the final course is 360 degrees minus angle B. With these couple of illustrations, I'm sure now you'll be able to get initial and final courses having calculated the internal angles A and B of the PAB triangle.
This one is also clear, beta. Let me know if you have any doubts in this. Okay, very good. So,
Sir,
हाँ बोलो बेटा.
sir, in this case, the final course 360 minus B, sir, ये थोड़ा बताओगे explain करो?
ओके बेटा, ओके. देखो बेटा, जो ट्रायंगल
सर
में
पूरा एक बार सर बता दीजिए ये वाला ना 180 और 360 वाला.
ओके इनिशियल फाइनल दोनों दोनों बेटा.
ये
ओके ओके
सर दोनों सर इनिशियल
ठीक है बेटा, अभी बता रहा हूँ. नाउ बेटा, जब हम कोसाइन फॉर्मूला से पीएबी ट्रायंगल को सॉल्व करेंगे, वी हैव द पोल हियर, द साउथ पोल, ए पॉइंट इज हियर, द बी पॉइंट इज हियर. व्हेन वी सॉल्व द पीएबी ट्रायंगल and calculate angle A of this triangle, that angle will be this one. Correct beta? I hope you can see my cursor.
yes sir, yes sir.
यस सर.
Right. So ये angle हमारे पास आएगा. Now हमें angle कौन सा चाहिए? हमें angle चाहिए starting from the north direction going clockwise up to the ship's head. So this blue color arc, dark blue color arc is what we require. हमारे पास कौन सा एंगल है? हमारे पास इंटरनल एंगल है इस ट्रायंगल का. नाउ ये जो मेरिडियन है बेटा, विच इज द लाइट ब्लू कलर आर्क मेरिडियन, at any point on the meridian, if you measure the total angle, this is 180 degrees, just like a straight line. So from this point, that is the north direction, if you come up to here, that is the south direction going toward the south pole, it will be 180 degrees. And from here up to the great circle track is my angle A. So my initial course would be 180 plus angle A. So is this clear now, beta?
यस सर.
yes sir, yes sir.
Yes, sir.
Okay, very good. Now let's come to the final course. In case of final course, the angle B which we are going to calculate is this angle. So this is the angle which we will obtain from the cosine formula. Now the angle which we require is this dark blue color arc starting from true north, going clockwise, going up to the ship's head. So this is the angle what we require. So how can we find this out? हमें internal angle भी पता है. Now this angle B will be equal to the external angle B. Why? Because when two great circles intersect, the opposite angles are same. Just like straight lines, when two straight lines intersect, the opposite angles are the same. So this outer angle will be equal to the internal angle P. Now if you go from north direction up to north, this is total 360 degrees. So if I subtract this outer angle B from 360, it will give me my course. So that is what we have done here. 360 minus angle B. That gives me my final course. So is it clear now, beta?
Yes, sir.
yes sir, yes sir.
Yes, sir.
Yes sir.
Okay. So for the courses, beta, always remember when you are calculating the courses, start from north. How can you identify the north? Look at the meridian going towards the North Pole. We know when we make this PAB triangle, the Papa Alpha and Papa Bravo are the meridians of two places. So just look at the direction of the meridian which is going towards the North Pole. The direction of the meridian represents the north direction. And from that north direction, remember you have to go clockwise The courses are measured in a clockwise direction from true north, and you have to go up to the ship's head. That is the definition of course. The angle between true north and the ship's head measured clockwise. That is what is the course of the ship. So always remember this. Start from true north, go clockwise and go up to the ship's head to find out your course. So is it okay now, beta?